Question one. Choose the correct answer for the following questions. One, standard normal distribution has, okay, a mean of 0 and standard deviation 0. And okay, now the question wants us to tell the mean and the standard deviation of the standard normal distribution. So we know a normal distribution has this. A normal distribution has a mean and standard deviation. But if we say it's standard normal distribution, we mean a normal distribution, but with mean 0 and standard deviation 1. So in this case, the standard normal distribution has mean 0, so its mean will be 0, and its standard deviation will be 1. So in this case, it will be just C. Now, which is not a property of standard normal distribution? So it is bell-shaped. It is, okay. Now, which is not a property of standard normal distribution? Now, here is a graph of standard normal distribution. It has a normal behavior. So the typical characteristics of a normal distribution is it's definitely bell-shaped. Here, this is bell-shaped, and it is symmetric about the mean. Okay, this is the mean here. The mean is 0. I mean, we're talking about the standard normal distribution. So its mean is 0 because we're talking about the standard normal distribution. And it's symmetric about the mean. Yes, this is true. So as you compare two sides of mean. And it is continuous. Yes, it is continuous. So the x values can take any value in this interval here and on the x-axis. And it says bimodal. Bimodal means if it's two modes, having two modes. So if it has two modes, it has to behave like this, There's the mode 1 here, there's one mode, and there's the other mode here. So we don't have this case in a standard normal distribution. So this is not a property of a standard normal distribution. Approximately what percentage of normally distributed data values will fall within two standard deviation above or below the mean? So this question, okay, is asking us 68, 95, and a 99.7 rule here. If you remember this rule, in a standard, in a normally distributed data, the 68% of the data here, the 68% of the data fall within 2 sigma, 1 sigma below or above the mean. Okay, so we can say, so this part here is 68, so mu plus sigma and mu minus sigma. And but it says that it's what percentage of the data fall within 2 standard deviations. So it means we have to go 2 sigma far from mu, so it will be just 2 sigma here and 2 sigma below and above, so it will be 2 sigma to this part and 2 sigma to this part, so we'll have mu minus 2 sigma. And it's asking now what is the percentage of this part. So this is, as we know, this is if it is 2 sigma here, 2 sigma above or below, means it's 195% rule. It's 95% of the data is fall within 2 sigma above or below the mean. So it will be just 95%. Now, which of the following is true property of normal distribution? The curve is symmetric about the mean. So if it's a normal distribution, we will have a curve like this one. So it's symmetric about the mean. Yes, the mean is the center here, and it's symmetric about the mean. And the curve is discrete. So this is not true. Discrete means the curve has this type of behavior, like this one, like the histogram. So it's not discrete, just continuous. So x will take all the values. It's not true. And the curve is bimodal. It says bimodal means it has two modes, two heights at the same height. So two humps with the same height, no. And the total area under the curve is 0.5, no. The total area here is the total area under the curve is just 1. So the correct answer is just A. Now, which of the following is not true about the normal distribution? So the mean, median, and the mode are all equal. So in a standard normal distribution, mean and the mode and, okay, the median, they're all same. It's coming from the symmetry. And the points of curve meet at the axis at y, y equal to -3 and y equal to 3. It never meets first. It never meets the x-axis, so it never touches. So this is not possible here. So it's not possible. It always has this behavior here. So if this is x-axis, it always approaches the x-axis, but it never touches. And this is true for both sides, for the left and right side. And this is never true. And also it says if at y equal to -3 and y equal to 3, cannot meet the x-axis for y equal to -3 or y equal to 3. Maybe I think it's meant to be x here. But in any way, this is not true. And the area under the normal curve is equal to 1. So this is true. This is true. Because the area under the normal curve is always 1. So it's built or designed this way, so it has to be 1. Because this is a probability distribution, continuous probability distribution, and it's symmetrical. Yes, it's symmetric. We can say it's symmetric with respect to the mean here. So this is true. And the only thing that's not true is C then. Okay, let's look at this question. Find the z-score that corresponds to the given area under the standard normal curve. So I think it's asking here, this one, the little z is here. So we want to find for which z we have this area, the total area on this part is 0.9564. So we can use a table here. Okay, we should use a table, but I think from these choices there is no need, because look at here. If it is 0, then this part will be 0.5. This half will be 0.5, and this area here, the green part, the left part, will be equal to also 0.5. But as we see, this part here, the area here is 0.9564. So basically, we will have such part, and z has to be less than 0. So this is clear from the picture. So which one is less than 0? It's obviously negative 1.721. let Z be the standard normal variable. Calculate the following probabilities. And we need a table for it. So this is, we know this is standard normal distribution table. Distribution table. Okay, table. And here, all these numbers are standing for the area. And area corresponding to what? Okay, so this is the normal distribution, and let's say this is Z. Okay, Z, here we have positive values here, so I will put Z here, some myriad for the positive values, little z. This area here, area to the left of Z. This, all these numbers are showing the area to the left of Z. So this area indeed is equal to the probability or the percentage of data which is okay, which has this property. Big Z is less than little z here. Big Z is the variable and little z is this number here. And this little z is corresponding to the numbers here, if you remember. Anyway, let's find this one. Z is bigger than, Z is less than or equal to 1.32. So it's asking, by the way, it's asking 1.32 is here. And we are, okay, we find the numbers less than 1.32. So it means this part here. If it is this part, we take this part of the graph. So how can we find it from here? We basically find, we break the number into two parts. 132, the 1.3, the first part, the second part, we can say 0.02, this one and this one. So 1.3 is this here, and 0.02 is here. So it will correspond to 0.90, 0.9066. And this has the same thing. I think there's a mistake. It has to be big Z here. So this is also, we do the same thing, 1.75. It has two components, 1.7 and 0.05. And we check from the table, where is this 1.7? So 1.7 is here and 0.05 is here. Then it corresponds to 95, 0.9599. Now, here we have in the other one in seed, in part C, we have a negative number. And first, let's try to see which part is asked here, because this area always gives to the left, okay, to the left of the little z, okay. But here it's asking which part. So this is negative 1.7, which is less than 0, and it's asking this part here. So because it says z bigger than, so we are talking about the numbers which are bigger than negative 1.7, so it has to be this part then, right of negative 1.7. But the problem here is we don't have the negative numbers. These are all positive z values. So we can use the table for the negatives, but I don't want to do it. Okay. But we can use the positive values also, this table. Now I will show you how. Look at this one. And now since it's symmetric, this is a symmetric distribution. Think about this. 1.7. So take this one, it's a negative 1.7, and take this one here, 1.7. So the positive 1.7. So as you see, this part here, uh, as you see, this green part and the red part here are same because of the symmetry around 0. So this part, they have the same area. Same area. So this means P Z, the probability that Z is bigger than 1 minus 1.70 is equal to the probability that z is less than uh, less than 1.70 here. So this part, this part is corresponding to that probability. This part is corresponding to that probability. But we know that mathematically, numerically are same. So I changed the question to a positive number question here. There's a positive number. So we can break this one into two pieces, 1.7 and 0.00. Now this corresponds to 1.7. Where is it? It's 1.7 is here, 0 is here. So then we end up with 0.9554. So this has to be 0.9554. So this question has to be equal to, okay, the answer is equal to 0.9554. Okay, this is one way of solving the questions without using the negative table. But if you have the negative table, you can directly do it from the negative table. But you have to subtract that value from 1, by the way. If you want to do it with the negative, you have to put 1 minus the probability that z is less than or equal to negative 1.70 and use the negative table here. But my way is here. I did the other approach, the symmetry. I used the symmetry. Now let's look at this question here. This value can be calculated. If there's an interval here, we know we have to calculate the probability that z is less than or equal to 2.5 minus the probability z less than or equal to 1.5. So we check this one. It has two parts here, 2.5, and the other part is 0.00. So here you can say here 0. This part, the first part is 2.5, and this 0 is corresponding to 0, 0. And the same thing is 1.5 and 0.00. And for this one, 2.5, it's here, and 0, 0 is here, so it's 0.9, 0.9938. It will be 0.9938. Then minus, okay, 1.5, where is it? 1.5, okay, 1.500 is here, 9332. So then the answer will be 0. Okay, there will be 6 here. It will be 0. It will be 6, and it will be 0 here. So the answer will be 0.0606. Now let's look at the last one. Now the absolute value first. The absolute is z value z less than or equal to 2.4. It means z is, from basic algebra, we know that this is corresponding to z less than 2.4, and z is bigger than negative 2.4. So z has to be between these two numbers. So we know how to do it, and this will be okay. You can write it this way, like p to 40. So this will be equal to z less than 240 minus z less than negative 2.4. So we have to find this one. We can use the negative table here. We have the positives here. We can find it. Now let's try to, okay, I will try to use a graph here. So I will make the graph here and try to get it from the symmetry. So here we have this 2.4, and here to negative 2.4, and then we want to get this one. Here this is 0. Okay, this part here, okay, what about finding this area? Because these areas are the same here. There's two ways. So we can say this is A, and then if I write it I mean, I can write this one as this area is 1 minus 2a, right? So what is this area? This area is clearly um, 1 minus the whole thing here. So this area. So what is this area? This, okay, forget about this negative 2.4 now. It will be the probability to the left of 2.4. So it will be z less than 2.4. So what is less than 2.4? It's here, and 0, 0, it's here. So this has to be 0.9918. So this a, little a, has to be 1 minus 0.9918, and a has to be then a has to be 0.0082, and then we can use it here, 1 minus 2 times 0.0082. This will be 1 minus 0.0182, 164, and which is equal to, as a last answer, I will say this is 0.900, 9,836. Okay, this is, I mean, I did it only by using the positive part, but also you can use this approach here, use negative table here, negative table, and from the positive table we already have this one. You can say this is 0.9918. Then you can, I mean, you can find a number from here, use the negative table here, and then when you subtract them, you will get the same thing here again. Okay, please check it, please. So check if you can get this one here again. The weights in kilograms of students of a certain school in a certain school are normally distributed with mean 40 and standard deviation 5. Find the percentage of students whose weight is less than 50, between 30 and 55, and more than 45. So here the x is the weight of student. So the weight of a student, let's say, and x is a normally distributed with the mean 40 and standard deviation 5. Okay, so this one is asking what's the percentage of the students. That means the percentage of the students who have weight less than 50. So it's the same as asking what's the probability that the weight of a student is less than 50. So the percentage of the data which is less than 50, or the percentage of the students less than 50, can be found by this. And how can we find this one? Now, since it's x, we have to be careful. We have to change x to z. So if you remember, we can change this to z by doing by using the mean and the standard deviation of x. So if you say x minus 40 divided by 5 is equal to z here. So use the same thing for 50 here, so convert them. So I will use the same thing, 40 minus 40, I mean 50 minus 40 divided by 5. So this has to be, this is equal to 2. So then we can write here, this is equal to the probability that z is less than 2 here. So we convert both x and 50 to z and the other corresponding value. Now z, okay, after this conversion, z has a normal distribution with 0, 1. So in this case, we can use the table here. So the table, so from the table, we have to look for 2 here. So 2 z is less than 2, so 2 has, okay, we can write it this way, like 2.00. So it will be 2.0, the first part is 2.0, and the second part here, the last one, we can write it as 0.00. So it has two components, 2, 0, and 0, 0. So the corresponding value will be 0.9772. So I will say this is 0.9772. And if you write it in a percentage, you can write it as 97.72%. So you can say the 97.72% of the students um, weigh less than 50. And we will do the same thing for the others. So let's write this one in terms of x. So we want the weight between 55 and 30. So we have to change it to z. So how do we change them to z? So we subtract 50, the mean, from all of them. Sorry, this is 40. So mu, this is just mu, 40. So 40. And then 55 minus 40. Divide by 5. 5 is here. Standard deviation. Now we will end up with this. This is automatically z. And this will be just 3, and this will be just minus 2. Now we changed the question to z. So now we write the question in terms of z. So it's minus 2. What's the probability that z is bigger than minus 2 and less than 3? Now in this case, we have to use the table here. So, but we can use the negative table here. By using the negative table, you can write this one as, okay, you can write it this way. Z, first, z less than 3 minus probability that z is less than minus 2. Okay, from here, you can find it from here, so it will be 0.99827. And from negative table, you can use this value. I mean, you can find this value and find it. But I don't have negative table here, so I will not be able to show it to you. So for this reason, you can do it. Okay, do it yourself here. With yourself with the negative table. But I want to use the positive table and the symmetry to find it. And if you want to do it this way, the positive values are enough to do it. So just you have to make a good graph. Negative 2, okay, 0 is here, and 3 is here, and then negative 2 is somewhere here. Or, okay, 3. So let's make 3 is too far, and minus 2 is a little far. Okay, now we want this z is between 3 and negative 2, so we are looking for the numbers that are between 3 and minus 2. Now, how can we get this one? Now, uh, again, for this one, I will use z less than 3, so it will be just the green part here, so this part, okay, the green part, and minus the navy blue part, which is this one. Okay, this one is coming from here, again, 0.9987, 0. Okay, white green here, 0.9987. And what about this part? So we are done with the green part. Now let's concentrate on the blue part here, this navy blue part. So how can we find it? So I will concentrate on finding this part here, z less than minus 2. Okay. Now, think about its symmetry here. Its symmetry will be 2 here, right? Sorry, this is a little close, so it has to be something like this here. 2 is here, okay? So as you see here, this navel blue part is equal to that part here. So that part, so how can I find this part here? So this was like 1 minus all these blue part, say this part. So I will subtract this part, but this part is corresponding to the probability that z is less than 2. And pz less than 2 is corresponding to 0.9772. So this has to be 1 minus 0.9772. And this part will be equal to then 0. So if you subtract, it will be 0.0300. No, it will be just 228. So now we found this one because, yeah, it was this one and it was this. Then we found it. Okay, by using the symmetry, now I will write it here. It's minus 0.02228. And when you subtract this one, it will be just 9 here. And that will be uh, 5 here. And then I think it will be 7 here. This will be 97. Okay, it will be 0.9759. So this has to be 0.9759. Okay, this is how you use the symmetry and the positive values to get the negative values, the probability for the negative values. And the other question is, what if, okay, what is the percentage of the students more than 45? Okay, so the weight of the students, the percentage of the students whose weight is bigger than 45. So we have to change it to z again. So you can do this, x minus 40 divided by 5. It's z now. And you do the same thing, and this is 45 minus 40 divided by 5, which is just 1 here. So it will be probability that z is bigger than 1. Now we can use the positive table for it, but let's remember this. Okay, this is asking the right part of, okay, the right part of the graph. So this part here. Here z should be bigger than 1, so we are looking for the values that are bigger than 1, so it has to be this part. But this table for the this table here for the positive values giving us the left part. So if you look at 1 here, 1 0, this is corresponding to, this value is corresponding to 0.8 of the green part. So this part here will be 0.8413. So what is the red part then? It will be just 1 minus probability that z less than 1. So which is the green part here from the table. So it's 1 minus 0.8413. And the answer will be 0.87 and then 5, and this is then 7. No, it's not. So it will be just 1. Okay, then you can say the probability, I mean, the percentage of the students who are who weigh made more than 45 is 15%, 15.87%. And of course, here we have to change it to percentage because it says percentage, so it has to be 97, 59%. The length of human pregnancy is not fixed, so it changes. It is known that it varies according to a normal distribution with a mean of 266 days and a deviation of 16 days. So find the value of z corresponding to 290 days, let's say, days of pregnancy. Now, we can say here there's x, let x be our variable. And what is the variable here? The length of the human pregnancy. So the length of pregnancy, the length of pregnancy in days. In days. Now, it is said that I mean the length of the pregnancy is varies according to normal distribution. So X has a normal distribution with mean 266 days and a deviation of 16 days. Now, it says find the value of z corresponding to 290 days. So it means if x is equal to 290, what is the z-score corresponding to that value? So the conversion between z and x is this, as we know, it's x minus the mean of x mu divided by sigma. So here the mu is 266 and sigma is 16. So we can write this one as z is equal to 266 divided by 16. Now, if x is 290, then we can say for x equal to 290, z will be equal to 290 minus 266 divided by 16, and which will be equal to 24 over 16, which is equal to 1.5. So then the z value corresponding to 290 is 1.5. And in the same way, we can do the second question here, find the value z corresponding to 222. And we will repeat the same thing. And we will get this one now. X is equal to 222. So what is z? And the relation between z and x is this. Now, if x is 222, so we will end up with 222 here and then 16 here. And this will be equal to negative 44 over 16, and which is equal to negative 2.75. If you use a calculator, you will see it's negative 2.75. Now, in that part of the question, it's saying what proportion of the human pregnancy is longer than 290 days? So proportion means the percentage. So it's basically asking what is the percentage, or we can say it this way, the probability that a human pregnancy is longer than 290. So you can say this one as the probability that X, a human pregnancy, is bigger than 290. Or the same way you can say this is corresponding to the percentage of the human pregnancies X values that are bigger than 290. Now, in order to solve this question, you have to convert this one to Z. And we know X is, I mean, if X is normally distributed with some mean, okay, if you remember, the mean is 200, I mean, the mean is 40, 100, sorry, 200, it was 240, I guess. It's 266, sorry, 266. And the standard deviation is 200. Standard deviation is 66. So this is given in the question. We wrote it. This is given in the question. Now, by using this, we have to change this one to z. So the relation between z and x is, we know z is equal to x minus mu, which is 266 divided by 16. And when you use this one, you will change x to z. So by using this transformation, it will be z. But in B, we also transferred it to 290 goes to 1.5, if you remember, because we did it this way. 290 minus 266 divided by 16, which is 24 over 16, which is 1.5. So we write it here 1.5. So we use the conversion. So if you don't know how to convert, so you can please check the related video, the lecture 12 video. There's a section about the conversion there. There's a slide. Now, what we have to do is now find the probability that z is bigger than 1.5. Now, z has, I mean, now the good thing about the converting to z is standard normal distribution. Z has normal distribution, which standard normal distribution. So it means you can use a table here. This is for the negatives. Now this is for the positive value, so I will use this one. Okay. Now these tables are always giving us this part here, the left part here. So we have to be careful. If you look at here 1.5, if you find 1.5 here, which is 1.500, so as you see here, this one, and I want to remind you 1.50, you can write it as 1.50, and you can make it into two parts, 0.00, so this you will take 1.5 and 00, and it corresponds to 0.9332. But from this table, what you get is only this part here, 0.9332. It's coming from the table. But this one here, this question is asking this part here, the green part. This is asking the green part, the values that are bigger than 1.5. So for this reason, how can you find this one? You will subtract this one, 1 minus 0.9332. Okay, in certain mathematical, I mean, if you want to write it mathematical way, this is equal to 1 minus the other side. I mean, this is asking the right side, right? So this is equal to 1 minus the left. So left means z less than 1.5. And this is coming from the table. This is negative 1 minus 0.9332. And this will give you 0.0668. So what does this mean? What's the answer of the question then? You can say, so you have to, it's asking the percentage. So this will give you 6.68% of women. Okay, so it means 6.68% of the pregnancies are longer than 290 days. Now, the second question is, what is the probability that a woman's pregnancy will last between 222 and 290? So in this case, in terms of x is the length of the pregnancy. We are looking at the probability that x is between 290 and 222. So you will convert this one to z again. So you know the conversion rule. It will be 290 minus 266 divided by 16. And this is 222 minus 266 divided by 16. That's 266 and, 16. This is the standard deviation and this is the mean of x. We already know that. Okay. And these values, we already found them in part A and part B. This is 1.5 and this is negative 2.75, from part A and part B here. these from part A and part B. You found them. Now then, we can say this is equal to now, this will be equal to the probability that Z is uh, less than 1.5 and bigger than negative 2.75. Now, what is this equal to? Indeed, this is equal to if you have an interval like this. So you will write this one first. Z is less than 1.5 minus, you'll write Z less than negative 2.75. So from the table for the positive values, since we have this way, this direction, Z is less than, so that we can use the table safely because it's the left side of 1.5. Z less than 1.5. It means the left part, and they're these tables are giving us the left side. So 1.5 means again we already found it here, 0.9332. So it's here. It's 0.9332. Okay, minus. Now, for this question only, I brought this. I included the negative table. I think this is the first time. And I will use this one here, the negative 2.75. So negative 2.75 has two components. So one of them is negative 2.7 and the other one is 0.05. And this will give you negative 2.7 and 0.05 is here. So this will correspond to that value here. So we can say now this value here is equal to 0.003 or 30. And when you subtract these, you will get the answer as, okay, the final answer will be 0. Okay, I will write it here. This is equal to 0.9302. So the probability that a woman's pregnancy will last between 220 days and 290 days is just 0.9302. Okay, that's it. Thanks for watching.